This reference guide is our second last reference guide for Unit 6. It is reference guide entry number 5, and it deals with our third and final form for writing an equation, which is called general form. General form is an equation, or a way of writing an equation that can be expressed in the form ax plus by plus c equals 0. So basically we are taking all of the values in the equation, and instead of isolating y as we did in slope-intercept form, we're moving everything to the left-hand side of the equation, or the right-hand side, and we're setting the other side as equal to 0. Okay? In this equation, a must be positive, and it must be a whole number. So it must be a positive counting number. It cannot be fractions or decimals or anything like that, nor can it be negative. B and C, meanwhile, are integers. Okay, so let's take a look at some types of problems that you could see. So this equation can be used to represent a linear function, the same as slope-intercept and point-slope forms could be. We've looked at those in reference guide entries 3 and 4 respectively, and this is just another way of representing the equation of a linear function. So much like those two forms, if something is in general form, it would have a domain equal to any real number and a range equal to any real number, and it would represent a linear function. Again, those are things that we have talked about in the past. In order to arrange an equation in general form, we move all numbers and their corresponding variables to the left side of the equation and set the right side equal to 0, or vice versa. Remember that x cannot be a fraction or decimal number. It cannot be negative. You have to deal with that if either of those two things occur. So let's take a look at how this would look. So you can see, and we won't spend too much time on what's to the left, but there is an example worked out for each of these styles of questions. That tells you what to do, written in green, and it does it just to the left with the equation. We're going to do that, but looking at our own equations with the problems to the right. Okay? So let's look at question B. Y minus 1 equals 3/5 x plus 2. Well, when we get to this equation, it's in point-slope form. Point-slope form to general form is often the transition that people find the most difficult. But what we can do with this to make it a little bit easier is let's just rewrite this in a slightly different way. Remember that this is the same as this. 3/5 multiplied by x plus 2 is the same as taking what's in the numerator and multiplying it by x plus 2 and putting the whole thing over 5. Now, why would I do that? The reason I would do that is because now we have a denominator that we can just get rid of. Then we can simplify each side. So let's take a look at how we would do that. The first thing I'm going to do is I'm going to multiply both sides by 5. So I'm going to go 5 multiplied by y minus 1 equals 3 multiplied by x plus 2 over 5 multiplied by 5. And of course that cancels out our 5 on the right-hand side. And it's going to leave us with 5 multiplied by y minus 1 equals 3 multiplied by x plus 2. Now we use the distributive property, and we multiply 5 by y to get 5y, and 5 by minus 1 to get negative 5. So we're left with 5y minus 5 on the left-hand side. On the right-hand side, again, we're going to use the distributive property. 3 multiplied by x is 3x, and then 3 multiplied by 2, of course, is 6. Now, in general form, everything gets moved to the same side of the equation. If x is already positive, well, it kind of makes sense to move everything to the side that x is on, because ultimately it's going to go ax plus by plus c. So the coefficient of x and x plus the coefficient of y and y plus the constant all equal to 0. So that means we're going to move everything on the left over. So we're going to start with the minus 5. And we all know how to move a negative 5 over. We add 5. that will leave us with 5y equals 3x plus 11. And now, again, we want everything moved over. This is a little different than some of the forms we've looked at before. So for example, in slope-intercept form, we just wanted to get y by itself. But here we want to move y over. We want everything on the same side of the equation. Well, to move 5y over, we're going to subtract 5y from both sides. That will leave us with nothing over there. And it will leave us with our equation in general form, which is what we wanted. Remember that your coefficient in front of x has to be positive and it cannot be a fraction. It's positive, it's 3, and it's not a fraction. 3 is a counting number, it's neither a fraction nor a decimal. So this is our equation in general form. Everything is on one side, x comes first, y comes second, constant comes last. Okay, and that is how you go from slope-intercept form, from point-slope form to general form. The example on the left, which we kind of skipped over, but I think I'll go back and talk about a bit more now, goes from point-slope form, slope-intercept form, to general form. And this is a bit easier of a transition to make. Here, we want to get rid of our fraction of 2/3 x. We want to get rid of that denominator 3. So you'll notice that the first thing that's done is we multiply both sides by 3. That makes it so that x no longer has a fraction, because we're going to multiply negative 2/3 x by 3, which will remove the fraction. When we do that, we end up down here at 3y equals 3 times negative 2/3 x. Well, 3 times negative 2 is negative 6. Divided by 3 is negative 2. Gives us negative 2x. And then we have to also multiply the 4 by 3 to give us 12. We have 3y equals negative 2x plus 12. We move the negative 2x and the plus 12 over, and we end up with plus 2x and minus 12, and then the plus 3 that was there originally. Okay, we'll do some examples of that in that form a little bit later on, but that's all that you would do there. If you do have a fraction in front of x, you multiply every value by that denominator. Get rid of the fraction first, then move everything to the same side of the equation. As you can see, is done in the example that's provided. So now let's move on to part B. Part B asks us to determine the x and y intercepts for the equations below. Well, they're both in general form. So let's talk about the one on the left, and then we'll do the one on the right. So you will remember the rule for intercepts. If you're finding the x-intercept, y equals 0. If you're finding the y-intercept, x equals 0. And you can see that happening here. So we're finding the x-intercept in the first one. Well, you can see right there that the person who's done this has set y equal to 0. And then we just multiply everything out. We want to solve for x in this case. Remember that when finding the x-intercept, you are isolating x. You set y equal to 0 and you solve for x. So we set y equal to 0 and it leaves us with 3x minus 18. Move the 18 over, divide by the 3, and we get an x-intercept of x equals 6. Same thing for the y-intercept, except instead of setting y equal to 0, we set x equal to 0, and you can see that being done right there. That leaves us, once we multiply 3 by 0 and of course get 0, leaves us with 2y minus 18. The 18 gets moved to the other side of the equation. We divide by 2, and we get a y-intercept equal to 9. And again, you can see all the work there, and what's written in green is what is being done to come up with those two answers. But let's look at one together, and we'll talk a bit more elaborately about each of the steps that we're doing. So the first thing we're going to do is we're going to find our x-intercept. And again, our x-intercept occurs when y equals 0. You have to remember that in order to do these problems. So we're going to go, and wherever I see a y in my equation, and there's only one of them, I will plug in 0. So this will cancel out. You don't have to put a big X through it, but I will. And it will leave us with x minus 9 equals 0. Well, our x-intercept means we solve for x. So we have to get rid of that minus 9 or that negative 9. And of course, to do that, we're going to add 9 to both sides. So the x-intercept occurs at x equals 9. Or, if you like to write the coordinates, 9, 0. So if the x-intercept occurs when y equals 0, well, then the y-intercept occurs when x equals 0. Let me just put a line here to separate those. So we're going to go back into our equation. And wherever I see an x, I'm going to put a 0 this time. So we're going to have 0 plus 3y minus 9 equals 0. That's going to leave us with 3y minus 9 equals 0. We move our negative 9 over by adding 9 to both sides. Leaves us with 3y equals 9. And of course, we've done this enough that we know to divide out our 3. And we get a y-intercept of y equals 3. Or, again, as some people prefer to write the coordinates, 0, 3. Okay? The nice thing about general form, there's a few nice things, but one of the really nice things about general form is it makes finding your intercepts much easier than they were with perhaps slope-intercept form, and certainly than they were with point-slope form. It's just one of the nice traits to having an equation that's in general form. Typically, your intercepts can be found with a little bit less headache than the other two forms that we've looked at. The last style of question that you may see, so you may see questions where you're just asked to put an equation in general form. You may see questions where you're asked to calculate your intercepts. Or you may see questions where you're asked to find the slope of a line that's in general form. Now, in order to do this, it's recommended that you take it out of general form and put it in slope-intercept form. Because if you do that, and you know how to read slope-intercept form, your slope will jump out at you. So that's what we're going to do. We're going to put this in the form y equals mx plus b. And you can see the example that's done over here where they have done that. So they have moved their x over and their 16 over, and they've isolated y. So divided out by the negative 2, which is the coefficient in front of y, to end up with this equation here. And once you have your equation, again, it's just a matter of remembering how to read slope-intercept form. Well, your slope, which is m, will be whatever is in front of x. In this case, it's 3 over 2. So then you can just pull out your slope, and you're done. So we're going to do that now with this equation over here. So the first thing we want is to isolate our y. Well, I'm going to start and do it a little bit differently than what's been done to the left. I'm going to move my constant over first. So I'm going to do it a little bit more. They move their x over first, then their constant. I'm going to move my constant over first. It doesn't matter. That will leave us with 5x minus 2y equals negative 12. Now I'm going to move my x over. So we move a positive 5x over by subtracting 5x. And that leaves us with negative 2y equals negative 5x minus 12. So my first steps in doing this, just move my x over, move my constant over, because our goal here is to get it in the form y equals mx plus b, which means we have to isolate y. So we move everything that isn't y over. And now we've isolated y, but it has a coefficient in front of it. And we've done this enough to know that that's not what we want. We want just y. We don't want negative 2y. And again, we've done this enough to know how to get rid of that problem. We divide out by negative 2. That will leave us with y equals negative 5 over negative 2 becomes 5 over 2. Negative 12 divided by negative 2 is plus 6. So we get this equation of y equals 5 over 2x plus 6. And again, so long as we know how to read slope-intercept form, we're okay there. Because we know that the slope is whatever is in front of x. Well, in this case, there's a 5 over 2 in front of x. So we know that that's going to be our slope. It doesn't ask for the y-intercept, but if it had, we would know that the y-intercept occurs when y equals plus 6. So we would just state, therefore, the slope is 5 over 2. Okay? And that is it. There are a number of ways that questions can be asked about equations in general form. These are 3 of them. The most common style that you're likely to see is just an equation presented to you in either slope-intercept or point-slope form that you have to then put in general form. You may also be asked to find intercepts. Again, bear in mind that finding intercepts typically is a little bit easier when the equation is in general form. The final style of question you could be asked to solve is equations where you're asked for the slope of a line that's in general form. And in those questions, just put in the form y equals mx plus b and pull out your slope.